Do you know? Take a look around you. Everything you see, every star in the night sky, every galaxy, every planet, and every fleck of dust, all of it, everything we've ever seen, makes up less than 5% of the universe. The rest, about 95%, is a cosmic enigma, an invisible world that surrounds and permeates us, yet stays completely hidden. This 95% is split between two distinct mysteries. About 27% is dark matter, and 68% is dark energy. So, what if the reality we perceive is just the glitter on a vast, invisible cosmic skeleton? What if the true architect of our universe is something we can't see at all? This is the shocking truth about dark matter. Section 1: The Cosmic Crime Scene. Our story doesn't start with a triumphant Eureka! But with a problem, a cosmic crime scene. Back in the 1930s, a brilliant and famously cranky astronomer named Fritz Zwicky was studying the colossal Coma cluster of galaxies. He carefully added up the mass of all the stars and gas he could see. But then he measured how fast the galaxies were moving, and the numbers just didn't add up. The galaxies were zipping around so fast that the gravity from all the visible stuff shouldn't have been nearly enough to keep them from flying apart. The whole cluster should have scattered into the void. To solve this, Zwicky proposed there had to be some kind of invisible matter providing the extra gravitational glue. He called it dunkle materie, dark matter. It was a revolutionary idea. And for the next 40 years, almost nobody paid attention. The universe, it seemed, didn't have enough gravity to hold itself together. Something was missing. Section 2: The Smoking Gun. Jump ahead to the 1970s. An astronomer named Vera Rubin, a true pioneer who shattered barriers for women in science, decided to investigate a similar puzzle on a smaller scale: individual spiral galaxies. Think of a galaxy as a spinning record. The stars near the center, where most of the bright, visible mass is, should move the fastest. The stars on the dim, outer edges should be moving much slower. That's just basic physics. If the outer edge of a record spun as fast as the center, it would tear itself to pieces. Using a powerful spectrograph she developed with her colleague Kent Ford, Vera Rubin measured the speeds of stars in the nearby Andromeda galaxy. Night after night, the data told her an impossible story. The rotation curve was flat. The stars on the very edge of the galaxy were orbiting just as fast as the stars near the core. This was the smoking gun. It flew in the face of the laws of gravity, as we knew them. Unless the galaxy wasn't just what we could see. What if it was embedded in a massive, invisible halo of matter? A halo with 5 to 10 times more mass than all the visible stars combined. Rubin and her team studied galaxy after galaxy, and they all showed the same strange behavior. Fritz Zwicky was right all along. The evidence was undeniable. Our universe is dominated by something we can't see. Section 3: Building the Case. But how can we be so sure? Couldn't our theory of gravity just be wrong on cosmic scales? It's a fair question. But since Rubin's discovery, the evidence for dark matter has poured in from completely different lines of investigation. One of our most powerful tools is gravitational lensing, an effect predicted by Einstein. The concept is straightforward: mass bends spacetime. A huge concentration of mass, like a galaxy cluster, acts like a giant magnifying glass in space, bending and distorting the light from galaxies located behind it. When astronomers use this method to weigh galaxy clusters, they find the same problem Zwicky did. The amount of lensing, the amount of gravity, is far greater than what all the visible matter can produce. By mapping this bent light, we can literally draw a map of the invisible dark matter. Then there's the ultimate proof: the bullet cluster. This is a crime scene in action: two galaxy clusters that collided head-on. The normal matter, mostly hot gas, smashed together and slowed down. But when astronomers mapped the mass using gravitational lensing, they found that most of it, the dark matter, had sailed right through the collision without interacting at all. It was like watching two ghosts pass through each other, while their physical bodies crashed and burned. This was stunning. Direct proof that dark matter is a distinct substance that barely notices the world we know. And finally, we can look back to the very beginning of time. When we observe the cosmic microwave background, the faint afterglow of the Big Bang, we're seeing a baby picture of the universe. This picture shows tiny temperature fluctuations. For these tiny seeds to grow into the vast web of galaxies we see today, they needed a gravitational kickstart. Normal matter alone wasn't enough. Only with an invisible scaffold of dark matter could these structures have formed in the 13.8 billion years since the Big Bang. Section 4. The True Architect. So, you see, dark matter isn't just a convenient fudge factor for a physics problem. It's not just missing mass. Its existence reveals a shocking truth. Dark matter is the master architect of the universe. It's the invisible skeleton that everything we see is built upon. In the early universe, dark matter started clumping together under its own gravity. Because it doesn't interact with light, it could begin forming structures much earlier than normal matter. It created vast, invisible structures called dark matter halos. These halos acted as gravitational wells, cosmic potholes on the smooth highway of spacetime. Over millions of years, ordinary matter, the gas and dust that would one day become you and me, was pulled into these cosmic basins. Dark matter is the backbone of galaxy formation. The stars, planets, and nebulae are just the brilliant decorations that settled onto this pre-existing, invisible frame. When we run computer simulations of the universe's evolution, the difference is staggering. Without dark matter, you get a diffuse, mostly empty cosmos. With it, you get an intricate, beautiful network of filaments and nodes, with vast voids in between, a structure known as the cosmic web. This simulation is a dead ringer for the large-scale structure of the universe we observe today. Dark matter built the cosmic freeways, and galaxies are just the cities that popped up at the interchanges. Section 5. The Unseen Suspects. The biggest question, of course, is what is this stuff? We know what dark matter does, but we have no idea what it is. It makes up about 85% of all matter, and trillions of its particles are probably streaming through you every single second. Yet we've never definitively caught one. Scientists are on a global manhunt, chasing down several leading suspects. One of the top candidates is a hypothetical particle called a WIMP, or a weakly interacting massive particle. These would be heavy, slow particles that interact only through gravity and the weak nuclear force, which makes them incredibly hard to detect. To find them, scientists have built ultra-sensitive detectors deep underground, shielded from cosmic rays, hoping for the faint signal of a WIMP bumping into an atomic nucleus. So far, experiments like the Zeppelin (LZ) detector have set world-leading limits on their properties, but have yet to find a definitive signal. Another prime suspect is the axion, a much lighter, ghost-like particle that was first proposed to solve a completely different problem in physics. Experiments like the Axion Dark Matter Experiment, ADMEX, use powerful magnetic fields to try and convert passing axions into tiny, detectable flashes of light. The hunt is on, but the universe is holding its secrets tight. CTA. The search for dark matter is one of the greatest detective stories in human history. New clues are being uncovered all the time by incredible facilities like the Vera C. Rubin Observatory. Beginning its decade-long survey, it is designed to create the most detailed map of this dark matter skeleton ever attempted. If you want to keep exploring the biggest mysteries of the cosmos, make sure you subscribe so you don't miss what we find next. Conclusion. The shocking truth is that we are strangers in our own universe. the reality we perceive, this world of light and familiar matter, is just a sliver of what's truly out there. We live inside a vast, invisible architecture whose nature we are only just beginning to grasp. The discovery of dark matter was a profoundly humbling moment. A shift in perspective as big as Copernicus realizing the Earth was not the center of everything. The stars we see at night are not the main event. They are just FAI, anti-embers, glowing on an immense, unseen cosmic scaffold. What that scaffold is made of, and what other secrets it might hold, remains the most profound mystery of our time. And the search for answers continues.